Hi, I'm Professor Stephen Simpson, and I was the inaugural director of the Charles Perkins Centre at the University of Sydney. And I'm also the executive director of Obesity Australia, which is the governing body for the Obesity Collective. I'm a scientist. I'm a biologist. I'm a basic biologist who started a career looking at obesity in insects, believe it or not. And I know through my decades of research how the basic biology of organisms, including humans, predisposes individuals to a risk or elevated risk of overweight and obesity if they're put in the wrong food environment. And that's a pervasive theme throughout all the work that I've done and my colleagues have done over the years. And it indicates 8 billion reasons, indeed, 8 billion and growing reasons why obesity is a fundamental part of the human condition. If not obesity itself, the risk of obesity. And the reason for that is that we have basic biological mechanisms, our appetites, our metabolism, our broad biology, which influences the way we grow and develop and maintain health or become ill across the life course. We have mechanisms that are shared by all organisms. And in the human condition, if you put those mechanisms in the wrong environment, we end up at risk. And that's precisely what we've done, because if you consider the genetics of obesity, the basic biology of obesity, of appetite, of physical activity, of metabolism, those things evolved in a world where we weren't surrounded 24 hours a day by highly processed foods, energy dense foods, foods that had been manufactured specifically to hack our basic biology. We lived in a world where we were urged, evolution urged us not to waste calories, to store them when they were in excess, not to needlessly run around and do exercise if there was no requirement to do that. You had to hold your resources. You had to seek sources of high energy food. And those mechanisms worked brilliantly for us and other organisms for millions of years. But now we've created a world in which all of our heart's desires have been met. The things that were once rare in our environment are now everywhere. Highly processed, energy dense, highly palatable foods, aggressively marketed, surrounding us everywhere. We're living in workplaces and homes and domestic environments where the built environment isn't encouraging us to be sufficiently physically active. All of these things are coming together in the modern world because we've had a fantastic capability, our brain, to build a world that in every respect meets our ancestral heart's desires. And the net result is that we're all at risk, some of us more so than others, depending on our genetics, of overweight and obesity in the modern world. Now, that's the sort of broad story. Let me tell you a little bit more about specifically what I do and what my colleagues do. And that is that we have started to explore over the years how it is that organisms, including humans, regulate how much we eat. How does appetite work? And how ultimately might appetite systems be subverted in the modern food environment? Well, working with brilliant colleague David Robenheimer, many years ago now, he and I were working in Oxford, where we discovered in experiments on locusts, that sounds unlikely, but it's true, that animals from locusts all the way to people don't just have a general sense of hunger or a general appetite. Rather, all organisms, us included, have specific appetites for different macronutrients. And among those specific appetites, the one that is most dominant and influences our behavior when it comes to food and how much we eat is an appetite for protein. We discovered this originally in insects and then went on to demonstrate it in a whole range of organisms, from slime molds to people. Now, if you think about it, if you've got a specific appetite for protein and your body cares about enough protein, you need to eat enough to gain the amino acids and the nitrogen you need to build new tissues, to reproduce, to essentially stay alive. If you have a very powerful protein appetite, then if you dilute protein in the food supply by adding, particularly adding in lots of calories in the form of industrially processed fats and carbohydrates, then your body is going to eat more calories. It's going to insist that you continue to eat more calories until you get to your requirement for protein. And this is an idea that we call protein leverage. So when you start to feel a need for protein, you start to crave umami, savory flavors. And in the modern world, umami and savory flavors come in abundance in the form of savory flavored snack foods, which are just like protein decoys. So when you start to need protein, we've shown what happens is your body releases a hormone, which is called FGF21. It comes from your liver. It makes you start to crave and desire savoriness, flavors that are sort of lip-smacking, proteinaceous, savory flavors. Now, if you then, as a result of that appetite, turn to the potato chips, you're eating a protein decoy. And what that's going to mean is that you're consuming calories driven by your protein-seeking appetite that are not in the form of protein, they're simply fats and carbs. So you're piling on excess energy without satisfying that fundamental driver, your protein appetite. And the biology of that process turns out to be extremely interesting and extremely powerful when it comes to the way in which our evolved biology has interacted with our changed food environment. Now, there's an example. It's an example of research into the basic mechanisms of biology that have been hacked in the modern industrialized food environment. It's an example of how there are 8 million reasons why obesity is relevant to us all, because that basic biology of appetite and the genetics underpinning it and all the metabolic consequences of it are common to our species. Indeed, it's not just us, it's all organisms that have similar sorts of mechanisms. But if you think about it, in the entire evolutionary history of life on Earth, we're the only species who's ended up in an environment we've been able to create ourselves to cause these problems, and no other species has ever had to resort to some of the devices that we've had to manage our food intake. It's a problem for the human species. It's certainly not an individual's fault.